In this demo we will showcase how to create a reorchestration from the Ai-MicroCloud UI, and how to spawn a Ai orchestration from the UI. After that, we will show how to run the MNIST example from a Jupyter notebook. We quickly create a Ai orchestration add-on. Create orchestration add-on. Type a name, for example, Ray Demo. Give it public access. In the compatible plans, select Zblock Small and Micro. As part of the default plan, select Small. Give it a description. This is Ray Demo Creation Orchestration. Select an image. Then create an orchestration. As can be seen, the add-on was successfully created. Next step. We will show how to spawn an orchestration add-on. First, I go onto the workspace and click on Spawn. Then, select the Ray Demo Orchestration. Choose the Intel Data Center. Choose the Orchestration Small Environment with this configuration of resources. Next, we choose Namespace, and choose this test environment, with a minimum of 2 worker nodes, and maximum of 4 worker nodes. Here I give the orchestration add-on a meaningful name. Let's call it Ray.io Demo. Then, spawn the orchestration. Depending on the complexity of the environment and setup, spanning an orchestration can take anywhere from a few seconds to many minutes. In this case, it should take a few seconds to a minute to spawn. The Ray.io dashboard is ready for usage. And we have 1 header node and 1 worker node. Now, we will show how to run an MNIST example. Open Jupyter Notebook. As can be seen, 1 worker node actually popped up, because we required minimum 2 worker nodes. So we open the Jupyter Notebook again. This is the code we have. We'll open the NIST code. This code will basically utilize the Ray Tuner for hyperparameter tuning and optimization aspect. Bring up a terminal. First, we create a Conda environment with Python 3.8. We do this with Python 3.8 because our Ray.io server is running on Python 3.8. Command is demo venv. This installation might take a few seconds. Then, we will activate our environment. The environment is activated. Here, a number of libraries are installed. We have the Ray.io library there by default. We have Ray Air. We will be using Ray Air most commonly. Ray Air will be utilized by Ray Tuner. Then there is Ray Serve, another library that will be used. Then we have Torch Vision, Torch Audio. We quickly install these libraries. The libraries have been installed. Then we run the NIST example. Then run. As seen in the header node, we see variations in CPU utilization. This is because the head is actually deciding the work to be assigned to different worker nodes, and if more worker nodes need to be assigned. That is why we see fluctuations in the CPU percentage. It takes warm-up time to actually spawn the whole experiment and model tuning. And as you can see, the memory is actually increasing. Now we see that tasks have been assigned to workers. We see different experiments running. Even in the worker nodes, the utilization has changed and is fluctuating. Even the head is actually running experiments. And we see that there are more worker nodes. Worker node 1, worker node 2, worker node 3, and worker node 4. There are 4 worker nodes. Experiments are also spawned in the various worker nodes themselves. Experiments are all running. Log files can be checked as well. Other information: store memory, how much disk being consumed. The memory consumption is represented. All of the resources are fluctuating because the experiments are still being run. Now we see the experiments have finished. The best configuration it found was this one: best configuration. The hyperparameters were basically the learning rate that is represented by LR. It is represented as momentum. Everything that is going on in the various experiments are logged and visible. All information, like stage, what is occurring, what all was tested, etc. Everything is finally entered and available for review here.